The most famous method of analyzing trusses is the method of joints. In the method of joints, a free body diagram of each joint is drawn. Because the forces at each joint are concurrent, equilibrium requires that the summation of forces in the x and y directions should be equal to 0. Thus, only two unknowns can be determined at each joint. The analysis begins by drawing a free body diagram of a joint with no more than two unknown forces proceeding from joint to joint so that each new free body diagram contains no more than two unknown forces. The method is self-checking because the last joint will involve only known forces. Let's look at this first example. A simply supported plane truss is loaded as shown in the figure. For values 30, 40, 45, 50, and 60 degrees, find the force carried by each link and indicate whether the link is in tension, T, or in compression, C. The first step is always to draw the free body diagram for the joint. Here, it is joint A. Since this is a symmetric truss, whatever the force is in AB is always equal to the force in the member link BC. We start by writing our equilibrium equations. The summation of y forces is equal to 0 and x equal to 0. For the summation of y forces equal to 0, we have FAB times sine theta plus 500 pounds equal to 0. From here, we will get an expression of FAB equals negative 500 pounds divided by sine theta. If we put in our equilibrium equation, summation of x forces is equal to 0, we will also have an expression for FAC of 500 pounds over tangent theta. Then plug in the numbers, or the values of theta. For example, if we plug in 30 degrees, we will find that FAB equals FBC equals 1,000 pounds in compression, and FAC equals 866 pounds in tension. Then we can fill in the table with all the other values that we need. If you want to apply the method of chance, always start by drawing the free body diagram for the problem. Then find the angles in the truss if they are missing, and find the reactions using the equilibrium equations. The summation of x forces equals 0, the summation of y forces equals 0, and the summation of a moment about any point in the structure equals 0. Once you are finished with the structure, then find the internal forces in the members. Start with the joints that have the least number of unknown forces. Typically, it will be the one near or close to the reaction. Find the x and y component of every force using equilibrium equations. Thus, only two unknowns can be determined at each joint. Let's look at a relatively more complex example. Shown in Figure A is a simple plane truss. Using the method of joints, find the forces in each member of the truss. Again, always start by drawing your free body diagram. Find the angles in the truss if they are missing. Then find the reactions using equilibrium equations. From the summation of x forces equals 0 equation, you will find that AX is equal to negative 4.5 kilonewtons. Applying a moment equation about A, we were able to find a value for dy and AY. If you want to check, you can use the third equivalent equation, which is summation of y forces equal to 0. Now we have our reactions, and we can proceed to find the internal forces of the members. We have our truss and free body diagram. Use joint A as the starting point, because we know that we only have two unknowns in joint A, which is the force FAB and FAF. Start by drawing a free body diagram for the joint. Find the x and y components for every force. There is an important distinction between analyzing the entire structure versus just analyzing the joints. To analyze an entire structure, use the three equilibrium equations. The summation of x forces equals 0, the summation of y forces equals 0, and the summation of moment about any point in the structure should equal 0. But to analyze the joints, you only use two equilibrium equations. The summation of x forces equals 0, and the summation of y forces equals 0. So looking at joint A, starting with the summation of y forces equal to 0, we have 2.5 plus 0.8 times FAB equals 0. From there, we will find a value for FAB of 3.125 kilonewtons in compression. If we use the summation of x forces equal to 0, you will find an expression for FAF, and from here you proceed to the next joint that has no more than two unknown forces. In this case, you should go to joint B. You complete the same steps. Draw a free body diagram for the joint, then put in your equilibrium equations. Using the summation of x forces equals 0, you'll find FBC as negative 1.875 kilonewtons in compression. Using the summation of y forces equals 0, you'll find an expression for FBF as 2.5 kilonewtons in tension. Continue repeating the process. Proceed to joint F, where you'll find an expression of FFC as negative 3.125 kilonewtons in compression and FFE as 8.25 kilonewtons in tension. For joint E, FED is 8.25 kilonewtons in tension, and FEC is 13.5 kilonewtons in tension. You should also apply the equilibrium equations for joint C and joint D. At the end, you will draw your final answer and put the numbers in the free body diagram. If the number is negative, the member is in compression. If it is positive, it means the member is in tension.